Hey guys, Mallory back. Today we're going to talk about Chapter 5 in our books, which is entitled Security, and the specific section we're going to analyze is encryption. Let's start off with what encryption is. Encryption, also known as symmetric key algorithms, are a class of algorithms for cryptography that use the same cryptographic keys for both encryption of plain text and decryption of ciphertext. The keys may be identical, or they may be a simple transformation to go in between the two keys. The keys in practice represent a shared secret between two or more parties that can be used to maintain a private information link. This is a requirement that both parties have access to the secret key. So one of the drawbacks of secret key encryption is, in comparison to public key encryption, was what we will get into later. So secret key encryption is when you can depict or decrypt our private messages. So somebody can encrypt messages without our key pretending to be us, which is a social ethical issue of privacy and reliability that is very important on the exam. So as you can see in this diagram, the secret key encryption, the original data is then encrypted with a symmetric key and then scrambled, and then the other party who isn't supposed to have access to the symmetric key has access, and it gets back the original data to be sent out and provide malice or cause harm to any of the parties or stakeholders. The history of encryption. Encryption goes way beyond what we think of it as today. It predates a long period. The Polybius square was an early cipher. These are just three main examples. It was used thousands of years ago to decrypt different textual documents. Then more recently, the Enigma machine was used in Nazi Germany to decipher different codes. And then most recently, the bombs in Colossus were a new type of innovation that were still computerless but used different ciphers to decipher encryptions that were used. About public key encryption right now. One of the weaknesses about symmetric key encryption is that two users attempting to communicate with each other each need a secure way to do so. Otherwise, an attacker can easily take the necessary data from the stream. Also known as asymmetric key encryption, public key encryption uses two different keys at once, a combination of a private key and a public key. So what this does is the private key is known only to your computer, while the public key is given to any computer that wants to communicate securely with it. So to decode an encrypted message, a computer must use the public key provided by the originating computer and its own private key. Although a message sent from one computer to another might not be as secure, since the public key is needed for encryption, it can be published by anyone who picks up the key and can't read it without the private key. One pretty popular public key encryption program is Pretty Good Privacy, PGP, which allows you to encrypt almost anything. So how it works is the sending communicator computer encrypts the document with a symmetric key, then encrypts the symmetric key with the public key of the receiving computer. The receiving computer uses its private key to decode the symmetric key. It then uses the symmetric key to decode the document. So just a little summation. To implement the public key encryption on a large scale, such as a secure web server or website, one might need to use a different approach, and this is what we're going to talk about in the next section. certificates. So as we're talking about, to such a secure web server might be needed. This is where digital certificates come in place. A digital certificate is a unique piece of code or a large number that says that the web server is trusted by an independent source known as a certificate authority. The certificate authority acts as a middleman that both computers can trust. It confirms that each computer is in fact who it says it is, and then provides public keys of each other to the computers. So in digital signature or digital signature scheme, we have a mathematical scheme for demonstrating the authenticity of a digital message or document. Valid digital signature gives a recipient reason to believe that the message was created by a known sender, such as they cannot deny sending it, authentication of it, and the message was not altered in transit. So those provide two social ethical issues to us of integrity and authenticity. Digital signatures are commonly used for software distribution, financial transactions, and other cases where it's important to detect forgery or tampering. Further, in cryptography, a public key certificate, also known as a digital certificate or identity certificate, is an electronic document that uses a digital signature to bind a public key with its own identity. In a typical public key infrastructure, the signature of the certificate authority will be used to provide provable security. So now a little bit about more of encryption in action. So there's four main types. Transport layer security is the standard encryption protocol used for the secure web communication, along with secure socket layer. So those are both used for logins to emails to provide and social networks, online banking, shopping transactions, things like that use HTTPS protocol. The next, extended valid SSL or EVSSL, is a digital certificate system designed to verify the identity of online organizations. Organization applies to the certificate authority or digital certificate. So the CA performs checks of the organizations to ensure that it's legitimate. Lastly, wired equivalent privacy or WEP is an older encryption algorithm used by wireless networks. It has kind of been superseded by Wi-Fi and protected access, but it still has protocols to keep data safe as if transmitted through different laptops and Wi-Fi routers. So those are just a couple types of the encryption that we see in everyday world. Encryption in hard disks. So data is stored on laptop computers and portable storage devices is particularly vulnerable to loss or theft. This can be prevented by using full disk encryption. So what this does is the programs encrypt every sector of the hard disk, including the empty sectors. So when the computer is first booted up, the user is prompted for a passphrase, which is used to decrypt the data from the disk. This happens before the operating system is loaded to prevent any malice. As the data is written to the disk from the memory, it is automatically encrypted, so no unencrypted data is saved onto the disk at any time. So this provides a vast security measure that really helps get down on tampering and different issues that associate with privacy. So overall, the main advantage of full disk encryption is that it happens automatically and transparently with every program after installation. Because I know ITGS is all about ethics. So encryption is essential to many industries, including e-commerce and banking. Without encryption, it would be very risky to purchase anything online. It wouldn't be done. Nothing would be purchased online. Too risky. Strong encryption effectively provides a guarantee that nobody without an encryption key can view the plain text. Overall, inability to break such encryption has even led to failure of criminal prosecutions against some cases due to lack of evidence. So that's a interesting dichotomy between how much encryption should we have and how much is it too much to hurt legislation. So one of the main things the U.S. has suggested is a key escrow, where an authorized authority holds users' encryption keys and reveals them to the law enforcement if requested. So we have a main social ethical issue of privacy and also policies and laws. To what extent can the government interfere and have control over the different types of encryption methods? Interestingly enough, in 2000, UK passed a controversial regulation of the Investigatory Powers Act, which required users to reveal their encryption keys. So we see that as maybe happening in the US in some time in the future due to all of the different lawsuits that have come about by encryption and hacking.